Dependency injection. This term sounds really fancy and complicated, but in reality it is a simple programming technique. The main idea is that when creating an instance of a class, the object receives its dependencies from an external source instead of creating them internally. Let's now take a look at an example, which is just moving characters. So manually I can move the player and the enemy is moving automatically using some calculations, and all of this is happening using the same script because I just wanted to make it reusable. So we have the player mover, which is a mono behavior. We can see that I'm storing some input type, which I have defined as an enum, and this one is telling us whether it should be controlled by the user or controlled by the computer. I'm also storing reference to the rigid body I want to move, and then I have two classes where one of them is handling the user input, so this one is just getting the input using the input class, and then we have the computer input, which is also doing some calculations pretty much for the AI, so these ones I'm also storing in the player mover. And then in start we just decide which one of these we want to use, and in update I'm just setting the velocity based off one of these two classes. To start using dependency injection, we first need to understand what is a dependency, and that are pretty much any classes on which this class is dependent. So right now one of the dependencies is the rigid body, because without it the class just would not work. It requires it to work properly. The same way as we have the user input and the computer input, these ones are dependencies as well, because without them this class just would not work. So this is the dependency part of the technique, and the injection means that all of the dependencies we have in the class should be received externally, meaning that from other class we can just provide the dependencies for this class. There are three ways using which we can inject dependencies into a class, and the first one is a constructor injection. This one is really the most common. So for the class into which we want to inject some dependencies, we need to make a public constructor, into which we'll just pass all of the dependencies externally. So this constructor will just set all of the dependencies based on the parameters that we provide it with, and to actually use the constructor, we need to create instance of this class, so then it definitely cannot be mono behavior, because of mono behaviors you cannot create instances. And then we'll need other script which will actually create the instance, so this one I will just call it player. So now in the player we can just store a reference to the player mover, which now is a non-mono behavior class, meaning that then we can just easily instantiate it, and you can see it is giving us an error because we are not providing the dependencies into the constructor. So back in the player mover, let's take a look at the start function, where before we are getting all of the dependencies. So I will just move this to the player class, so we can remove the start completely. Anyways, this class would not be able to use the start anymore because it's not mono behavior. From the player mover, I will also move the input type variable, and I will move the definition of the enum as well. So now the player class is starting to fill up. Let's first take a look at the rigid body dependency. This one I would just rather assign through the inspector, so I make it a serialized field variable. I also made local variables which are storing the user input and the computer input. So again we are just deciding whether the computer should be moving it or the user. And now we can get back to the player mover class. So as we are instantiating it, we can pass in the user input, the computer input, and the rigid body as well. And that's the whole concept of dependency injection. Right now we are passing all of the dependencies externally into the player mover, so inside of the player mover we now don't really need to create them or get them any other way. And there is one more thing we need to change in the player mover for it to work, because the class is no longer mono behavior, then the update would not be called automatically, so I will just rename it. I will also make it public, and then we will jump back to the player class, where on update I will just call it using the player mover reference we have, so player mover.move. So back in the scene on the player and on the enemy, we obviously now cannot have the player mover, it's not a mono behavior, so instead let's drag in the player, and now for the player I will select that it is the user, I will drag in the rigid body from the inspector. For the enemy, this one should be the computer, and again we have the rigid body. And now it seems to work, the enemy is moving, it changes the direction, and the player can move as well. Great! So this is the first and the most common way how we can inject dependencies into a class, which is using constructor. The second way is using a setter function, and this means really what it says, so we create new function inside of which we'll set all of the dependencies, so now we no longer need the constructor for it. So it is this simple to make a dependency injection using a setter method. But I still prefer the constructors, because they actually require you to set all of the dependencies, whereas if you are using just a public function like this one you can easily forget to call in the class where you are instantiating the player mover. So in this case, back in the player, into the constructor I cannot pass any parameters, so right now it allows me to instantiate the class, but then I would need to remember to go into the player mover and call the function setDependencies, which sometimes you can forget. And there is also a third way to do the dependency injection, which is similar to the setter, and that is using an interface. So you'd create an interface like this, where you'd create the function again, setDependencies, into which you need to pass all of the dependencies, and then the class which requires them can just inherit from the interface. So now in this class it requires you to use that method, and just like so we have the dependency injection using the interface. But for now I will keep it using the constructor, because this one really requires us to fill in all of the dependencies. You can see that dependency injection is really not scary and it is quite simple to implement. Using dependency injection has many benefits, such as improved reusability and testability, and the main reason for that is now we can really instantiate the player mover class anywhere and we can pass in different dependencies. So now the dependencies are not actually handled inside of the player mover and we can really pass in whatever we want. I also want to talk about the dependency inversion principle. The main idea is that a class should not be coupled with a specific implementation of other class, but rather with an interface. So in my case, the player mover is really just coupled to the user input and the computer input. If I would want to add another way of input, let's say some controller input, I would need to modify this class as well. So instead, let's create an interface iPlayerInput. This interface is really simple, it just has one function which will return us the move vector, and this is what both of the input classes have in common. So the computer input needs to return us the move vector, and the same way with the user input. So let's make the user input extend from the iPlayer input the same way the computer input. In my case I don't need to make any changes, because both of these classes already have the getMoveVector function which the interface requires. So now back in the player mover, we don't really need references for the specific implementation of the input class, we can just require the interface instead. We can see that the class is a lot shorter now, and the great thing about using an interface in this case is that the player mover class now doesn't even know where it's going to get the input, it just cares that it receives some iPlayer input from which then it can get the move vector. So this class is now not tied to a specific implementation of the input, but it can really get the input from any iPlayer input class. And back in the player class, as we are passing the dependencies into the player mover, we can just pass in the iPlayer input that we select. And another great thing about using the constructor in the player mover is that now we can easily catch some errors. So in here it would be no problem just to do some if check to check if the rigid body is not equal to null, and the same way with the player input. If you would not be using dependency injection and the rigid body and all of that code would be scattered along this whole class, it would be really hard to find a place where we could do this simple check. I hope that from now on you will be using the dependency injection a lot more. You can see that in Unity it can be a bit harder, as the dependency injection can be used just with non-mono behavior classes, but this should also serve as a reminder that not all of your classes have to be mono behavior. In fact, in many cases it is better to create less mono behavior classes. So now you know how to use the dependency injection and how to use the dependency inversion principle. Using both of these, it will help you to improve the testability, reusability, separate the concerns throughout your code, and mainly decrease the coupling between classes and their dependencies. And if you are interested in learning more about the MVC pattern and the command pattern, which I have both covered on this channel, then take a look at my Patreon, because there I have released a new video where I am connecting those two patterns together and creating an application using them, so you can see how we could use those two patterns in a real scenario. I hope that this video was useful. If you have any questions or suggestions, let them down to the comments. Don't forget to like, subscribe, and I will see you in next videos. Bye!